Hello everyone. Today we'll continue to solve some other exercises for our Cogito Olympiad. So let's see with this one. In the addition shown P and Q represent single digits. What is the value of P plus Q? So we have the addition of three digits number, and we have some digits which are denoted by P and Q. We have to find what is the sum of them, P plus Q. Since P and Q are digits, it means P and Q will take a value from 1 to 9. From 1 to 9. Well, P can be 0 because it is the last digit, but Q cannot be 0, okay, because it is the first digit here. So even 0 can be included. Okay, now let's analyze what is given. We have P plus P plus P. Okay, so the units are all P. Will give me 7. So it is like 3P will give me 7. Okay, 3P will give me 7. Since 7 is not a multiple of 3, it means this value must be 17 or 27 or 37. Okay, we have to analyze this case. It cannot be 17 again because 17 is a prime number. It can be 27 if P is 9. Okay, so if P is 9, we can have 9 plus 9 plus 9 is equal to 27. Okay, so the unit will be 7. Can it be 37 or more than 27? Well, we know that the biggest digit that we can take is 9. So since 9 plus 9 plus 9 will give me 27, it means I cannot have any larger value. Okay, so I cannot have 7 because 7 is not a multiple of 3. I cannot have 17 again for the same reason. It is not a multiple of 3, but I can have 27, which means P is equal to 9. Okay, we found the value for P. P is equal to 9. Now, if P is 9, we said the result will be 27, so I will have 2 here. So 2 plus 7 is 9. 9 plus 2Q, okay, 9 plus 2Q, Q plus Q is 2Q, will give me again a number which has the last digit as 9, okay, because P was 9. So this number can be 9, okay, or it can be 19 or 29 or 39 and so on. We have to check. So if this sum is 9, it means 2Q is equal to 9 minus 9 is 0, which means Q is 0. Okay, if Q is 0, we can check 9. Then 7 plus 6 is 13, not 19. Okay, because here I have P as 9. So 9, 9. So Q cannot be 0. Okay, again, 2 plus 7 is 9. This one is 0, and I put it here 9. 7 plus 6 is 13, plus 0. Again, it will remain 13, not 19. So Q cannot be 0. Now I have to check for the sum 19. Okay, if it is possible. So 2Q will be equal to 10. 19 minus 9 is 10. Q will be equal to 5. Let's check if this one is true for 5. So 9 plus 10 is 19. So I have 1 here. Okay. 13, 14 plus 5 again is 19. So this result will be true. So Q can be 5 when P is 9. Let's check for 29. Is 29 a possible value? 2Q, okay, will be equal to 29 minus 9, which is 20. Okay, 2Q is 20. Q is what? Q is 10. Can Q be 10? Okay, since we know that 10 is not a digit, Q cannot be 10. So the only possible value that Q can take is 5 and P is 9. So the sum of P plus Q will be 14. Okay, in this kind of exercises, you have to analyze all the possible cases for each of the letters or unknown variables that are given to you. Let's see the next one. The area of a rectangular is 16 and 1 over 2. If one side is 6 and 3 over 4, how long is the other side? Okay, so what is given? It is given the area of a rectangle. Okay, so we have a rectangle. We have a rectangle. The area of this rectangle is given. The area is 16 and 1 over 5. Okay, the area is this one. And one of the sides is 6 and 3 over 4. Let's say this one, this side is 6 and 3 over 4. We have to find what is the other side. We know how to find the area of the rectangle. We can say that area of rectangle is length times width. Okay, length times width. It means this side times this side. Since area is given, we can substitute in place of area 16 and 1 over 5. Okay, is equal to, the length is given, it means one of the sides is given. It is 6 and 3 over 4 times W, the ones that we have to find. To perform operation with mixed fractions is better if we convert them into improper fractions. To convert it, we know that we have to multiply 16 with 5 and add 1. So 16 times 5 will be 80 plus 1, 81 over 5. Okay, 16 times 5 plus 1 is equal to the same thing for the second fraction. I have 6 times 4, 24 plus 3, 27 over 4 times W. So what is the length of this side? It will be area divided by one side. Okay, 81 over 5 divided by 27 over 4. So we have a division of two fractions. And to perform this division, we have learned we have to do 81 over 5 times 4 over 27. Okay, we can simplify 81 with 27. 3 will remain. Okay, 81 divided by 27 is 3. 3 times 4 is 12. So the result will be 12 over 5. Now let's check the answers. Do we have any 12 over 5? No. But we know that this one is improper fraction, so I can convert into mixed number. 12 divided by 5 will give me what? 2. Okay, minus 10. And what is the remainder? The remainder is 2. So as a mixed number, this one will be 2 and 2 over 5. Okay, 2 whole. And the remainder is 2, 2 over 5. So the answer will be B, 2 and 2 over 5. Okay, let's pass to the next question. This one is a nice question. When expressed as a repeating decimal, the fraction 1 over 7 is written as 0.142857, 142857. So it means it is what kind of number? It is a recurring decimal. Okay, this one is repeating infinitely. If you remember from the last hour that we did together, we talked about how to convert this kind of numbers into fractions. Okay, we learned how to convert them into fractions. So this one is that kind of number, a recurring decimal. So these 6 digits continue to repeat until infinite. The digit in the third position to the right of the decimal point is 2. Okay, we can see that the digit in the third position, thousands, is 2. In which of the following positions to the right of the decimal point will there also be a 2? Now we have to check in which of these positions we'll have 2 again. To do this, we have to analyze we have to know the number of the repeating decimals. There are 6, and 2 is in the 3rd position. So after each 6 decimals, 6 digits, the number repeat. This means I have to divide each of these numbers with 6 and to find the remainder. Okay, then the remainder, if the remainder is 3, it means this number will be 2. If the remainder is not 3, then this position won't show me a 2. So let's start with the first one, with A. 119 divided by 6. So it is 1. Okay, minus 6, it will give me 5. 59 divided by 6. Okay, this one will give me 9. Minus 54. So the remainder here is 5. Okay, so this number will show me which digit, the 5th. Okay, the 5th digit, which is 5. So this one is not 2. Let's try with 121 divided by 6. Again, I have 12 divided by 6 is 2. Okay, minus 12, 0, 1, it is 0. Okay, minus 0. What is the remainder? The remainder is 1. So this position will show me the first digit, which is 1. 123. Since for this one the remainder was 1, now 121. For 123, the remainder will be 3. Okay, so the remainder that we want. So the answer will be C. Okay, since the remainder is 3, it means after 120 turns, I will finish, okay, this 7. I will go after 7, after 120 turns, because it is divisible by 6. Then I will have to, if the remainder is 3, it means I have 1, 2, 3. So I will go to the 3rd digit, which is 2. This is the way how we solve this kind of problems. Let's see the next one. Delia's birthday is on Wednesday, and Bruce's birthday is 60 days after Delia's. On what day of the week is Bruce's birthday? So this one is like the example that we solved. Okay, like this one again. We know that a week has how many days? 7 days. So if I start from Wednesday, I will have Wednesday, Thursday, okay, Friday, Saturday, Sunday, Monday, and Tuesday. Okay, in total I have 7 days. So since the birthday will be 60 days after, it means I have to divide this 60 with 7 days and find the remainder. So 60 divided by 7 is what? It is 7, 8. Okay, 8 minus 56. And the remainder is 4. It means when it goes to Wednesday, okay, after 8 weeks, he will finish in Wednesday. Then we'll start to count this 4 remainder ones. So 1, 2, 3, 4. Okay, so his birthday will be on Saturday. It means after 4 days after he finished 8 weeks. 8 weeks later and 4 days. So the answer will be Saturday. Now we have this kind of exercise. We have solved exercises like this. Again, we have to use the sum of consecutive numbers. A is 1 plus 2 plus 3 plus 40, and B is 1 plus 3 plus 5 plus 17 plus 19. I have to find A minus B. So since A are all the consecutive numbers until 40, B are all the consecutive odd numbers until 90, which means if I subtract them, A minus B will be what? 1 plus 2 plus 3 plus, and it continues, plus 40. Okay, minus, let's put bracket here, 1 plus 3 plus 5 plus 17. Okay, this one continues. And plus 19. Now we have some common numbers which will subtraction of which will give me 0. Okay, so 1 minus 1 is 0 if I subtract from here. 3 minus 3 is 0. 5 minus 5 is 0. Okay, 17 minus 17 will be 0. 19 minus 19 will be 0. So until 20, I have taken out all the odd numbers and I will have only the even ones. So I will have 2 plus 4 plus 6, okay, plus 20 until here. Then I have plus what? 21 plus 22 plus 23, okay, plus 40. So I have to divide this addition into two parts. One part is the sum of even numbers which have the difference 2, okay, and the other part is the sum of consecutive numbers from 21 to 40. If we divide in this way, we have to use the formula that we have learned. We have said that I have the last term, which is 20, plus the first term, which is 2, okay, times the last term, which is 20, minus the first term, which is 2, plus what? Plus the difference between each term. Until 20, I have the difference 2. Okay, plus 2 over 2 times difference, 2 times 2. Okay, so this one will be the sum of the numbers from 2 to 20, plus, now I have the sum of consecutive numbers from 21 to 40. Again, the same formula. I will have the last number 40 plus the first one, which is 21, times the last term minus the first term, okay, plus the difference, which is 1 in this case, over 2 times difference, 2 times 1. Let's perform the operations. I will have 22 times 20 over 4, okay, plus I have 61 times 40 minus 21 plus 1 will be times 20, okay, over 2. Okay, we can simplify 20 with 4. It will give me 5. Again, 20 with 2, 10 will remain. So I have 22 times 5, which is 5 times 2, 10, 110 plus 610. So this sum will be 720. Okay, the sum of the numbers is 720, A minus B. So this one will be the answer. Okay, let's continue with the next question. A and B are two natural numbers, and A plus 4 is 3 times B. If the sum of A and B is 76, then what is A minus B? So it is given a word problem, and we have to convert this one, first of all, into equations. So since I have two unknown numbers, A and B, and the sum of them is 76, it means A plus B, okay, A plus B is equal to 76. Then another relation is given. What is this relation? A plus 4 is equal to what? 3 times B, okay, is equal to 3B. So now I have two equations and I have to find A minus B. So to find it, let's try to find the value of A and B. since I have two equations with two variables, I can solve them by using the system of equations. So if I write A in terms of B at the first one, I will have A is equal to 76 minus B. Okay, it can be written like this. Then I will go to the second equation, and in place of A, I will substitute this value. So 76 minus B plus 4, okay, is equal to 3B. So I get an equation which has only one variable now. Okay, this is the aim. Let's solve this equation. 76 plus 4 is what? 80 is equal to 3B plus B. I will pass B on this side with plus. It will be 4B. So what is B? It is 80 divided by 4, which is 20. Okay, B is 20. If B is 20, what is A? Then we can go here and substitute. A will be 76 minus 20, okay, which is equal to 56. Now let's check if it is right or not. 20 plus 56 gives 76. It is okay. A plus 4, which means 76 plus 4 is 80. Is it as 3B? Sorry, 76 plus 4, 80. Is it the same as 3B? Yes. Okay, so this solution is right. Sorry, 56 plus 4 is 60. 3 times 20 will give me 60. So they are right. Okay, so the answer is right. In this way, you can solve the equations if we have two unknowns. Now, 11. A child organizes her toys in sets of 3, in sets of 4, and in sets of 5. And each time there is only one toy remaining. At least how many toys does she have? Now, what is given? It is given that a child has X number of toys, okay? So it has X. We don't know the number. And she groups, or he groups these toys into sets of 3, into sets of 4, and into sets of 5. And the remainder is always 1. What does it mean? So if she or he groups these ones into sets of 3, it means this number is divided by 3. Okay, it will give me a result A, and the remainder will be what? 1 at this division. Same thing, this one is divided by 4. It will give me an answer B. It means four sets with B toys each, and the remainder again will be 1. And same thing is for the last one. X, okay, is divided by 5. It will give me a value C, and the remainder will be 1. Well, how can I write it in a different way? It means this X minus 1, or X minus 1, okay, is equal to what? 3A. Okay, I can express X in this form. X is equal to 3A plus 1. Okay, so 3 sets with A toys plus 1 will give me X. And after that, I can paste the 1 in this side. It will be 3A. From this equation here, I can write as X minus 1 is equal to 4B. Okay, and from this one, I can write again X minus 1 is equal to what? 5C. Now, what can we say for this number X minus 1? It can be expressed as 3 times A, 4 times B, or 5 times C, which means this X minus 1, in fact, is the least common multiple of 3, 4, and 5. Okay, it can be the least common multiple of 3, 4, and 5. So what is the least common multiple of 3, 4, and 5? Since they are relatively prime number between them, it will be 12 times 5, 60. Okay, so x minus 1, sorry, x minus 1 must be 60 or a multiple of 60. X minus 1, not x. X minus 1 is 60 or a multiple of 60, which means the number that we are looking for is which number? The number 61, because it is the least value. We can have 121, okay, or we can go 181 and so on. It means the multiples of 60 plus 1 will give answer to this problem. But we need the least one, and the least one, we know how to find the least common multiple. Okay, so this one will be the answer. Exercise 10. It is not a difficult problem. Susie's 5-meter long ribbon had shaded and unshaded sections of equal length as shown. The point A, B, C, D are equally spaced along the ribbon. Okay, so we have this ribbon. It is divided into 4 parts which have equal length, and then one of these parts is divided into 3 parts as it is given. Now, if Susie wants a ribbon that is 11 over 15 of the sides of this ribbon, at which point should she make a single vertical cut? So in total here we have 5 parts. And these letters have divided each of these parts into 3 equal parts. So if I make this division into all the other parts, the division that A, B, C, and D have done, in total I will have how many parts? 3 times 5, 15 parts. Okay, and 15 parts are the parts that I need. So I have 3 plus 3, 6 plus 3, 9. To make 11, I need how many parts? 2 more parts. So I'll take 1, 2. Okay, so Susie must cut the ribbon here at point C. Okay, because here she will get 11 over 15 parts. At a factory, 11,410 kilograms of rice is distributed equally into 3,260 bags. A family uses 0.25 kilograms of rice each day. How many days would it take this family to use up 1 bag of rice? Okay, I think that this problem is not so difficult for you. So this rice is distributed among how many bags? 3,260 bags. Okay, so first of all, I have to find how many rice take 1 bag. Okay, for this one, I have to divide 11,410 with 3,260 bags. Okay, I have to perform this division. Then a family, well, let's perform this division. Let's find what is the result. So the result of this one is 3.5. Okay, 3.5 kilogram of rice will be in one of the bags. Okay, in 1 bag. Okay, a family uses 0.25 kilogram of rice each day. So for 1 day, I have 0.25 kilogram. And 1 bag has 3.5 kilograms, so I have to divide 3.5 to, okay, what? 0.25. We can write them as a fraction to perform the division. 35 over 10 divided by 25 over 100. Okay, which is 35 over 10 times 100. We have to reverse the second fraction over 25. So now we can simplify 35 and 25. Okay, will be simplified with 5. This one will give me 7 and here 5. Again, 10 can be simplified with 5, and it will give me 2. So the result is 7 times 2, which is 14 days. So one bag can be spent or can be used by a family for 14 days. Okay, the answer will be 14. How many even natural numbers are there between 21 and 195? We know how to find how many numbers are between two given numbers. Okay, we said we have to subtract the largest number from the largest number, the smallest one, minus 21 and minus 1. Okay, and minus 1, sorry. So what will be the result? 174 minus 1, it is 173. So in total there are 173 numbers between these two numbers, 21 and 195. How many of them are even numbers? We know that the even numbers and odd numbers between two numbers will have will be the same value of them. That's why the half of this one will give me the even number. So it will be what? 22, 24, 26. If you order 22, 24, okay, 26, and it will go until 194. Okay, even we can take like this. So the half of these ones will be even, and the other half will be odd. So 173 divided by 2 is what? 100. Sorry. I have 173 divided by 2. Okay, the half of the numbers. So 17 divided by 2 will give me 8. Okay, 16. So 13 divided by 2 will give me 86. And the remainder is 1. So there will be 86 even numbers between these two numbers. And the other 87 numbers are odd numbers. Okay, the other ones will be odd numbers. Okay, let's continue with this one. Consider the set 0.34, 0.304, 0.034, 0.43, these decimal numbers. What is the sum of the smallest and the largest number in this set? So first of all, we have to find the smallest number. Well, the smallest number, we know that we have to compare starting from a whole part, then the tenth, hundred, thousands, and so on. So this one is the smallest. The largest one, since the whole parts are all 0, then I have to check for tenth. It is 3304, which means this one is the largest. So the sum of them will be 0.464. Okay, so the sum of them is this number. Okay, and the last question. In the diagram, 4 different integers from 1 to 9 inclusive, it means 1 and 9 is included, are placed in the 4 boxes in the top row. It means in these 4 boxes, I have to put the numbers from 1 to 9, okay, the integers from 1 to 9. The integers of the left boxes are multiplied, okay, these two are multiplied and give this number, and the other two are added. The result is divided, okay, the result of them then is divided. The final result is placed in the bottom box. Okay, here I am, the final result. Which of the following integers cannot appear in the bottom box? In this kind of questions, we have to check. So let's suppose that here I have 6. Okay, so which number divided by another number will give me 6? It can be 18. Okay, I have to try. 18 divided by 3. I'm taking from or 12 divided by 2. I am taking all of them and I will check if it is possible. So 18 divided by 3. So for 3 I have what possibilities? 1 plus 2. Numbers from 1 to 9. At this one, to get 18, I can put which numbers? 3 times 6. Okay, so 3 times 6 is 18. 1 plus 2 is 3. Their division will give me 6. So this one is possible. There can be a lot of other opportunities for this one, okay? A lot of them. If I found one, it is okay. So 6 is possible to be put it in the bottom box. Now let's check for 7. If we find one example for 7, that is okay, it is okay. So let's check 7. So 7, I can write as 28, okay, dividing by 4, or 14 divided by 2. But 14 divided by 2, here I have to put 1 plus 1, which is not possible. So let's take 28 divided by 4. So here I can put 1 and 3 again, will give me 4. And 28 is what? 7 times 4. Okay, only these ones must not be repeated. The first 4. So 28 divided by 4 is 7, and this one is possible. So since I found one example for 7, it is okay. Now let's check for the last one. Okay, for 24. If I have 24 here, okay, here I have to put what? Let's say 48 divided by 2. It's not so possible because 2 must be 1 plus 1. Let's say this one is 3, so let's write 1 plus 2. So 3 times 24 will give me what? 72. And I can write 7 times 8 here. So even 24 is okay. Okay, so the one that remains is 20. Let's see even for 20 if we can find the possible value or not. So if I have 20 in here, okay, if I have 20, for 20 I can have which division? 40 divided by 2. Okay, it will be 1 plus 1, which is not possible. Let's have a number which is divided by 3 then. Okay, so I can write 1 plus 2 in here. So if it is divided by 3, it will be 60. To get 60, I must multiply 6 to 10. Okay, there is no other possibility, but 10 is not a digit, the digit that I'm looking for, so I cannot write this one. If it is 4, it will be 80. So always the number which divides the number here, okay, must be a number which ends with 0. And to get a number like that, I must have, or I must multiply with 10 in here, which is not possible. That's why 20 cannot be a value in the last one. Okay, so this one was the questions that we have to solve or to revise for our exam. I hope you do well in exam. So let's see you.